Welcome back to Merrill Math. I'm Mr. Merrill, and today we're going to be talking about powers of I. I, as you're aware, or maybe you're not aware, hopefully you're aware, because if you're looking up this video, you're probably in Algebra 2. I is defined as the imaginary number. Now you have to be careful about that designation, imaginary. Imaginary doesn't mean unicorns and stuff like that. It means basically the opposite of the reals. So imaginary doesn't mean it doesn't exist. Imaginary means it's different than the real numbers, and we're all familiar with the real numbers. I, the imaginary number, is the square root of -1. So that means that if we square it, which is a power of I, that means we get -1. So that's probably the easiest power of I to do, to the first power and to the second power. But what if we go further? So if we extend this and we say I to the third, so I times I times I, or I squared times I. We know what this is. This is -1 times I. Well, that would just be -I. All right, fair enough. I to the fourth. Well, we have two I squareds that we can break apart here. So then we have -1 times -1. Well, that's just +1. What if we want to go further? This is a good method. I mean, just breaking it apart and looking at the powers. This is a good method for smaller numbers. But when the powers get larger and larger, it's a lot harder to do that because, well, it just is really time consuming. So what we're going to look at, let's see, how do I want to turn this? Let's do it this way, just to be proper. What we're going to look at is just a little graph here. Let's call this the complex plane. So this is the complex plane. It looks a lot like the coordinate plane, but we have the real numbers on the x-axis that we're used to, and we have the i's on the y-axis. So these are the positive imaginary numbers. These are the positive real numbers. These would be the negative real numbers, and this is the negative i's. Okay, so if we take I to the first power, let's say we're right here. Let's say this is I. Now, something about the complex plane that's really interesting, and we're not going to get into in this video, is if you multiply two complex numbers together, what happens is a change in the magnitude of the number and the direction of the number on the complex plane. So this is a really interesting concept, and we'll talk about this in a later video. But the main thing I want to talk about here is a multiplication by I, which is what we're doing, is powers of I, results in a rotation on the complex plane of 90 degrees. And that's useful to us because our coordinate system is based on two 90-degree axes. So notice that if we did I to the first, we got I. If we did I squared, we got -1. If we did I to the third, we got -I. And if we did I to the fourth, we got +1. So all of these numbers, I didn't space these out right, but that's okay. I'm kind of trying to look through a camera, and I've got a microphone in my face, so forgive me. But we get the point here. I is rotating 90 degrees each time. So what that means is there's a pattern, and we can figure it out. So what we're going to do is we're going to take this information and we're going to put it into a chart. Let me move off to the side here, and let's look at a chart. So if we combine some information here, let's say I have, well, let me take a step back. Let's look at this again. We know that I to the first is here, I squared, I to the third, I to the fourth. One thing we didn't talk about was I to the 0, and this is going to make our lives a little bit easier here when we're looking at this. Anything to the 0 power is always equal to 1. Now that's useful, and we also expect that because, well, 90 degrees backwards from here, so I to the first and then I to the 0, we expect to go clockwise instead of counterclockwise. So I to the 0 is 1. So we're going to combine some information here. So if we have, let's see, let's try and make a chart here. So we have powers here. So to the 0, to the 1, to the 2nd, to the 3rd, and then to the 4th, to the 5th, to the 6th, to the 7th, to the 8th, to the 9th, to the 10th, to the 11th. And for each of these powers, we notice that as we're looking at our grid here, so we have to the first, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you wanted to, you could just, whatever number you were dealing with, you could just count in circles over and over again. But there's an easier way, even than that. So for each of these, we have, let me extend a little bit upwards here. So we have some answers here for each of these values. So let me finish my chart here. So I to the 0 power, so these are all powers. I to the 0 power we know is 1. I to the first, well, that's just I. I squared is -1, and I to the 3rd was -I. So we got that from here. 1 to I to the 3rd, that was -I. So this chart can give you powers as far as you want to count. Now, let's say somebody gives you like I to the, 107th power. So we have I to the 107th power, and we're like, oh, geez, I don't want to write that out, continue my thing clear down. We don't have to do that. What we can do is use remainders. So because we have 4 things in this chart that are repeating over and over again, this is a cycle, there is let's say a subset of mathematics, and it's likely that you haven't heard of this, but that's okay. It's called modulo or modular arithmetic, and what this has to do with is division, but not worrying about what the quotient is. What we're concerned with is the remainder. So this basically is the arithmetic of remainders. So what we're going to do, let's say we have I to the 107th power. What we want to do is we want to take 107 and we want to divide it by 4 and get an answer, but we don't care what the quotient is. What we're looking at is the remainder. So we take 4 into 10, and that's 2. Let's see, we got an 8. I'm going to do some subtraction here. 4 into 27. Let's see, 4 times 6. That's 24. We're going to subtract. That gives us a 3. This is what we're looking at. So our remainder tells us where we're going to end up in this chart. So notice that 100 is divisible by 4. So 100, 101, 102, 103, 104, 105, 106, 107. So we would end up in this column. And that's another way to do it. You could just think of like a multiple of 4 that's close to where you are, just count from there. But this is the really quick way to find powers of I. So let's do another example. How about I to the, let's think of a good one. How about 331? So I to the 331 power. Now, we wouldn't necessarily want to do this, and we wouldn't necessarily want to break these apart like that. What we want to do is get the answer. We want to get the right answer, but most importantly, we want to get the answer quickly. And this is the way to do it. So we're going to take 4 into 331, and you can do this on your calculator. Actually, hang on a minute. Is there a calculator nearby? Oh, there is. Okay, I'm back. Okay, so take a look at the calculator. This is probably different than the calculator you have, but that's all right. So what we want to do is take 331. Let me see if I can zoom in here by lifting it instead of messing with the camera. And we want to divide it by 4. So we get an answer. Let me see if I can get that glare off of there. Okay, so we got 82.75. Okay, so our calculator tells us this. And our question is, what does that mean? Well, since we're dividing by 4, a remainder of 1 is, whoops, wrong column. A remainder of 1, that's the 0 column. A remainder of 1 is 1/4 or 1/4, right? A quarter is worth 25 cents. 2 quarters is worth 50 cents. 3 quarters is 75 cents. This is a remainder 3 problem. So if you get a 0.25, that's a remainder of 1, a 0.5, that's a remainder of 2, and a 0.75 is a remainder of 3. If it goes in evenly, there won't be anything after the decimal. So let's say, let's see, what did we have? We had 331. So if we did instead, let me go back. If we did 332, we shouldn't get a remainder. We divide by 4, and we get 83. And that doesn't have a remainder. There's nothing after the decimal point. If there's nothing after the decimal point, that's a remainder of 0, and you're in your 0 column, which means your answer is 1. So the answer to this one, I to the 331 power, we have remainder 3. We're in the 3 column. That is negative I. I don't know if you saw me write that because the paper was down lower. All right. So this is kind of a relatively short video. I think I've gone on for a little longer than I intended, but it's a short method. Maybe I talked about it for a while, longer than I wanted to, but it's pretty quick, it's pretty easy, and hopefully you can have some success with it. If you have any questions, comments, points of clarification, be sure to leave those in the comments below. Otherwise, thanks for watching.